Okay, lesson P.2. You may look at this and say Cartesian coordinate system. We've never done that before. I don't know what that is. You've been doing Cartesian coordinate systems since, I don't even know what grade. When did you guys start graphing? Okay, Cartesian coordinate system is the official terminology for just your XY axis. Okay, we will look at, if we get time at the end of the year, I usually try and throw in the polar coordinate, or, graphing with polar coordinates. We don't really do the three-dimensional thing, but, so you guys know what you're doing on this. This is total review. So, as we look at this, talk to me. Which one's the X, which one's the Y axis? Nothing?
Like on the graph?
Huh?
Like on the graph?
Yeah, which one's which?
Horizontal X.
There you go. Yeah, so horizontal's x-axis, vertical's y-axis. Which quadrant's which? There's 4 quadrants. Their names are quadrants 1, 2, 3, 4. Where's 1? Okay, so 1 is top right, and we usually write these in Roman numerals. Not really sure why, but they're always written in Roman numerals usually. Not that you have to. Where's 2 go from there? Top left. We go counterclockwise here, don't we? So over here is quadrant 2, and then keep going. Quadrant 3 is bottom left. Quadrant 4 is bottom right. Okay. We're being asked to plot some of these ordered pairs. What do you remember about an ordered pair? What's the order in an ordered pair? XY. The ordered pair is XY. Okay, so let's practice with some of these. Negative 5, 8. How do we graph negative 5, 8? Negative 5 tells me to go left 5, because your X tells you left or right. So we're going to go left 5, and I'm just going to put some, what I call tick marks here. And then what's 8 tell us to do? Go up 8. And I'm just putting some tick marks. It's not going to be hugely formal here. There's my point, and I'm going to call this point A, because it was problem A. So we went left and we went up. What quadrant did that land in? Quadrant 2. And I'm just getting ahead of the game because that question's asked at the end. Okay, what about B? 0, negative 2. How do we graph 0, negative 2?
Up nowhere.
What?
Up nowhere. Or over nowhere.
Which is it? Is it up nowhere or over nowhere?
It's over nowhere.
Okay.
Get nowhere.
And then?
Down to it.
Okay. So the 0 says, I say left or right 0. So that's going to stay. And then the negative 2 says we're going to go down 2. I'm going to call that point B. What quadrant is that in? Okay, it's between quadrants 3 and 4. It's on the y-axis. Okay, so depending on how you're being asked, you could answer either way of those. What I'm going to say is, what quadrant is it in? I'm going to say none. I mean, it is on the y-axis. It is on the border of quadrants 3 and 4, but it's not specifically in a quadrant. Okay, 5, negative 3. Where are you going? Which way 5?
Right.
Right 5. And which way negative 3? Down 3. I'm calling that point C, and that is in quadrant what? Quadrant 4. Okay. 4, 0. Where is 4, 0? 4 tells us to go right 4. 0 tells us to stay. I'm going to call that point D. What quadrant is point D in? It's not. Okay. You could say it is on the border between quadrants 1 and 4. It is on the x-axis, but for my purposes, I'm going to say no quadrant. -3, -2. Where are you going? -3 says left. -2 says down. Both numbers left or negative, you go left and down. This is in quadrant 3. And point F, 3.5, 7.5. Can we graph that? Yeah, you can graph that. You go 3.5 boxes, which I don't even have boxes on here. So 3.5 to the right, and then 7.5 up, which from earlier I have 8 marked, so I think it's going to be about there. And I'm calling that point F. And point F is in quadrant 1. That is pure review, isn't it? That was, wow, we wish all pre-cal was going to be this easy. Unfortunately, we're moving on. Okay, absolute value. What do you guys remember about absolute value? Nothing? What do you do for absolute value? What's the definition? What comes to your brain?
Just the distance away from 0.
Okay. Our official definition is distance from 0, isn't it? So officially it's the distance from 0 on a number line. So what does that make happen then? If I ask for the absolute value of a positive number, then the answer is positive. What if I ask about the absolute value of a negative number? It's positive, right? Because if you go 5 left on a number line to get to -5, that's still a distance of 5. Distance officially in this sense cannot be negative. So we always think that absolute value makes the number positive, right? Okay. So there's kind of an official definition of absolute value here. And it'll kind of make sense once we go through the examples. But the absolute value of A, if A is bigger than 0. So the absolute value of A, if A is already positive, is just itself. It's A, right? That's what we know. Okay? The absolute value of A, if A is less than 0, and notice it says negative A here. But what that's really saying is it's saying it's the opposite of A. So if A is already negative, the absolute value of A isn't going to be itself, it's going to be the opposite of A. Because the absolute value of a negative number will become positive. And here it's saying the absolute value of 0, if A is 0, the absolute value is 0. So it's just kind of a formal definition. What we have to think about is this one, or these, okay? So evaluate means I just want a number answer here. What is the absolute value of -4? Because the distance from 0 to -4 is 4. Okay, we got the easy one that you've been doing since middle school out of the way, right? Okay, now let's come up to level here. Absolute value of pi minus 6. Thoughts? Okay, she's suggesting would it be pi plus 6? No, that's what we have to start somewhere, right? We have to start with some guesses, some thoughts. Let's talk and reason this out. She's asking, would it be pi plus 6 because we want the positive? Is that how you something like that, right? Okay. I need the discussion to start somewhere, right? So this is what I want to hear. Good. Okay, Jacob?
Would it be negative pi plus 6?
Why would you say negative pi plus 6?
Because if it's pi plus 6, then it'll be like 9 point something. That'll be r.
Okay.
issue was.
You're right on it. Here's what we have to look at, okay? And the pi plus 6, I'll be honest, you got the obvious mistake out of the way right off the bat. So that's what we need. I need to hear that to get that out of the way. Because we don't want to change the value of this expression. So even if I don't grab the calculator, what do you guys know about pi? Pi is what? We know without even grabbing the calculator, I know some of you guys have grabbed the calculator, but just if I'm just going for estimation purposes, right? 3.4 minus 6 is going to be what kind of number? Negative or positive? This value is going to be a negative value, right? So what is the absolute value of a negative? The positive version of that. So 3.4 minus 6, okay, if I just estimate for my head purposes, that's like approximately negative 3-ish, right? Not exactly, but negative 3-ish. So the absolute value of negative 3 is positive 3, right? So the absolute value of this needs to be around positive 3. Well, if we just change this minus sign and say pi plus 6, now we're at 9-ish instead of 3-ish. Does that make sense? So this is where that definition earlier, if a is less than 0. So my value is negative. It is less than 0, right? So that means we're going to do the opposite of a, which means if I do the opposite of a, I'm doing the negative of pi minus 6. So because pi minus 6 was a negative value, a value less than 0, we're going to do the opposite. And what is the opposite of pi minus 6? Multiply everything by a negative, and it becomes negative pi plus 6. So I don't know if Jacob had that full understanding there, but that's where he was right, he was on the right track. That now, if I do this math, negative pi is like negative 3.14 plus 6. Well, if I do negative 3 plus 6, am I at positive 3-ish now? I am. And you, of course, can go specific on the calculators. So does that make sense? If what's inside the absolute value has a negative value, basically multiply it by a negative 1. Okay? Essentially, that's what you could do here. This is a negative 4. If you take negative 4 and multiply it by negative 1, you get positive 4, don't you? Okay, questions? Have I made my explanation clear? Okay, what about C? Absolute value of square root of 5 minus square root of 2. Thoughts on this one? What do you know about square root of 5 minus square root of 2? Square root of 5 minus square root of 2 are going to be positive or negative? Positive. And we know that because square root of 5 is bigger than 2, right? So square root of 5 minus square root of 2 is going to be positive. So right now, what is inside those absolute value bars is a positive, right? So how do you do the absolute value of a positive? It stays the same, yes? The absolute value of a negative, we had to basically multiply by a negative 1. The absolute value of a positive is going to be the same number. So it's still going to be square root of 5 minus square root of 2. It doesn't change. Absolute value of a positive stays the number as is. Questions there? It's kind of a spin on what you've always thought of absolute value. It's logical if you think it through, but it is definitely a spin. Okay. Distance formula. You've been using this distance formula since middle school. I reviewed it with my calculus kids yesterday. It's just one of those things that comes up at the beginning of the year. So given two ordered pairs, x1, y1 and x1, y2, the distance between those 2 points, does it seem familiar? D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That's the difference between 2 points on a graph. Okay, so we're going to use that here in a moment. There is also given A and B on a number line. So if you just have points, say points 5 and points -3, then in order to find the distance between those on number line, you can just do the absolute value of A minus B. Okay? So let's look at example 2. Find the distance between 1, 5 and 6, 2. What do you know about an ordered pair? Ordered pairs are always XY, XY. Okay? So as I fill this in, I'm going to say D is the square root, and it's x2 minus x1 quantity squared. It doesn't matter which x you pick, which order you do your x's in here. So that means we can either do 1 minus 6 or 6 minus 1. I'll be honest, I tend to go bigger minus smaller. So I'm going to go 6 minus 1 quantity squared. Plus, now we do the y's. Officially, I should be consistent. So since I said 6 minus 1 on the first one, then for the second one I should say 2 minus 5. Well, I'll be honest, we're going to square those quantities, so it's not going to matter. Okay, let's see. 6 minus 1 is 5. So 5 squared plus 2 minus 5 is -3. -3 squared. Keep doing the math. What's 5 squared? 25. What's -3 squared? 9. Don't let the calculator tell you -9. Be smarter than your calculator. 25 plus 9 is 34. So depending on what you need, you could possibly say the distance is the square root of 34. Can you give me a decimal answer? I believe it's a second function on these, isn't it? Yeah. It's kind of like your scientific calculator. It's probably a second function on your scientific calculator. 5. I have 5.83 is what I have listed. So if I do second and the square root, you guys can't see what I did, sorry. But second button and the square root is right above x squared. Okay. That's just an easy application of your calculator. So either square root of 34 or 5.83, depending on what, the situation is. I can't remember what homework wants off the top of my head. Real quick before we move on to midpoint, what about the distance between -7 and 19? You might not even need a formula there. How far are -7 and 19 apart? Hmm? 26? Because you've got 7 to the left, 19 to the right, so 7 plus 19 makes it 26. If you want to use that formula, it's the absolute value of A minus B. It doesn't matter which value you do first, because it's going to do the absolute value of it. So if I do the absolute value of 19 minus -7, well, that becomes 19 plus 7. So the absolute value of 26, which is 26. Okay. Midpoint formula. I feel like it's 6th, 7th grade, somewhere in there you learn distance formula and midpoint formula, right? You learn them together, usually in the same lesson. I don't know, maybe you even learn them in elementary. I don't really remember when you learn them. Probably not, because I don't think you learn square roots in elementary. And this is where I'm trying to think, has Natalie learned square roots? And I'm not sure if she has. My Natalie, of course. So
I think we did like very basic, like maybe up to
some basics.
Maybe 10.
And maybe, yeah.
Square root of 100.
Like the base of the perfect squares. That's possible. Okay, midpoint formula. Given two ordered pairs, x1, y1, x2, y2. Basically, to find the midpoint, you're going to add the x's, divide by 2. Add the y's, divide by 2. And that's going to find the midpoint between two random points on a graph. Now, on a number line, the key is to just add the numbers and divide by 2. That's going to find the middle there. So, example 3. The midpoint of the line segment with endpoints negative 5, 2 and 3, 7. Add your x's, divide by 2. Add your y's, divide by 2. So my x's are negative 5 plus 3, divide by 2. And then we're going to put a comma, and then we're going to do the same thing with our y's. So comma, and with the y's it's going to be 2 plus 7 divided by 2. So negative 5 plus 3 is negative 2. Negative 2 divided by 2 is going to make it negative 1. 2 plus 7 is 9. 9 divided by 2, 9 halves. I would be perfectly fine with the ordered pair negative 1, comma 9 halves. What's the other way that some of you wrote this? Yeah. I would also be perfectly fine with negative 1, comma 4.5. We don't do a whole lot with mixed numbers, so you probably wouldn't see a 4.5, but improper or decimal, either or. Okay, what about the midpoint on a number line between negative 6 and 9? How do we find that midpoint? We're going to take those two numbers and basically find the average. Add and divide by 2. Negative 6 plus 9 is 3. 3 divided by 2 is? Okay. I'm fine with 3 halves. The other option is 1.5. Whatever makes you happy there, guys. This class is really ending in like 2 minutes.
Hi, Jerome.
I was supposed to be a little farther than this. However, is this today I had written in my notes as a questionable, are we going to get through it? It did. Yeah. Okay, I did have written in my notes. I wasn't sure if we were going to get through this or not. I was hoping to. Okay, so obviously it's a good stopping point since we have a minute left in class. Not my plan. I'm glad I looked at the clock though. So there's a homework written on the board. Those are all evens. Okay, so 2 through 18, 24 through 28, and 38 to 52, all evens on page 17. Based on the fact that it's likely we're going to start class late tomorrow too, I'm going to say this homework's not going to be due till Friday. Okay? Then after that, we are going to get back on a one-day thing. But based on the fact that we'll probably get a late start in class tomorrow, plan out me doing it on Friday. You're welcome to get started, but it won't be due tomorrow. Maybe some work time.